Welcome back. We're going to now talk a little bit more about the assignment operator. So let me remind you what we did a little while ago. We talked about the assignment operator, x equals 42. X is a variable. It takes on a value. That value in this case is an integer. It can be a long integer. It could be a float. It could be a string. And there's other types that it can be that we'll be talking about in the coming weeks. And we also saw expressions where you do things like sum two values, multiply two values, divide two values, and so on and so forth. And now we're going to start to put those pieces together and look a little bit more carefully at the assignment operator to make sure that we understand how it works. So let's go ahead and just get started. So let me remind you again that when you see that equal sign, that is an assignment operator. It is not a statement of equality. I'm not saying x is equal to 5. I'm saying x is being assigned the value of 5. And again, in your head you should have this idea that somewhere in computer memory there's a little cupboard with a label on it. That label says x, and inside of that cupboard is the number 5, so that when you go to ask for the value of x, either to print it, to use it in expression, or whatever it is, it reaches into memory, looks up what the value of x is, and hands it back to you. Okay? So at this point, we've assigned the variable x the value 5. And it's not really that critical in Python because you don't have to declare this to be an integer, but we should keep in our head what these types are, because as we saw in the previous lecture, the type of a variable does matter when you're doing even something as simple as an arithmetic operator. Okay, so that's the first command. Let's do another assignment operator. I have a new variable, y is equal to 6. So now in memory, I have two cupboards, x, y. In x is stored the value 5, in y is stored the value 6. I try to be very careful with the words. Pay attention to that word, the value 5. I'm not storing x, I'm storing a number, in this case the value 5 and 6. Okay, so let's do a couple more. So now I'm going to assign x again to the value of 4. Okay, so x is equal to 5, y is equal to 6, x equals to 4. And so now the question you want to ask is, well, what happens when I have this double assignment in some ways? And what happens is that when I did that first line, Python went into memory and said, is there an x here? No? Good, let's create a new x. Same thing for y. And then here, Python goes into memory and said, oh, there's a value of x. Please rewrite it. That is, x is no longer the value of 5. I have reassigned it the value of 4. So in this first one up here, I assign it. And in the second value, because it's been assigned before, I reassign it to a new value. So at this point in memory, x is equal to 4 and y is equal to 6. So that's important to understand that I can reassign variables at any time. Okay, good. So now let's look at the expression. So here again is an expression. On the left-hand side is a variable assignment, and on the right-hand side is an expression as we saw in the previous lecture. This, of course, is simple addition, and I want to add two things. Now, when you look at these assignment operators, please keep them, what's happening on the right-hand side of the assignment operator, separate from what's happening on the left-hand side. On the right-hand side is a function call, an expression, something that has to be evaluated, something that has to return a value, whether it's an int, a float, a string, or whatever. Okay? So let's start there. Once we have a value, then we can assign it to a variable, in this case z. Okay, so let's go ahead and evaluate that expression. Please sum up for me x plus 1. Well, what is x? Well, let's go find out. Let's go and look into memory. Okay, we go into memory, we grab the value of x. Okay, what is the value of x? All right, let's go back up through our code. It was initially 5, y was equal to 6. That has no impact on x whatsoever. And then we reassigned it to 4. So now x is the value of 4. I grab that value from memory and I shove it right there. And now I have an expression with two values, 4 and 1. I sum them up, 5. I take that value and I create a new variable called z, so that when I print z, of course, I get 5. I don't get 6. X does not have the value of 5. Y is irrelevant to this particular expression. So x had the value of 4. I sum that to 1, and I get 5. And z in memory is 5. I didn't just print 5. I printed z, and z still is somewhere in memory with that value associated with it. Most importantly, z is not x plus 1. Z has no memory of that. Z is simply a number now because this expression evaluated to a value. Okay, let's look at a few more examples. Please set for me x equal to 5. So, and then print z. So we'll get to that print z in a second. So let's first, skipping over the prints, x was initially set to 5. Y has no impact on x. X is reassigned the value 4. Z is set to be x plus 1. We already saw that that's 5. Okay, next statement, x is 5. What happens here? What is the current value after evaluating this line of x? That's right, it's 5, because I've now reassigned it again. It was initially 5, changed it to 4, and now it's 5 again. Now the question is, what happens when I print z? Okay, so let's see. Well, think about it for a second. It seems to me there's there's lots of answers, of course, but there's two reasonable answers. One answer is, well, z is equal to x plus 1, so that's going to be 6, because x is 5 now. But the other reasonable answer is, up here, z was assigned the value of 5, and this didn't change the value of z, and this didn't change the value of z, so z is equal to 5. So those seem like the two somewhat reasonable answers. Which one do you think it is? Good, think about it for a second. Well, I actually gave you the answer a few minutes ago. I said, when z is being assigned, this assignment statement, z is not x plus 1. Z is 5. So what I mean by that is z has no memory of how it got the value that it got. And so when I reassign x here, it has absolutely no impact on z whatsoever. Z is still 5. Okay? So that's really important, that these expressions aren't stored in memory. What's stored in memory is the value, the result of evaluating the expression. All right, let's do another example. Same thing, x is equal to 5, y is equal to 6. What happens at this line? After I evaluate this, what is the value of x? That's right, it's 4. It's 4 because it was originally 5. This had no impact on x, of course, and then I reassigned it to the value 4. So here's a funny looking expression, x is equal to x plus 1. So again, separate please the right-hand side of an assignment operator and the left-hand side. What's on the right-hand side? An expression in this case. What's on the left-hand side is to take what that expression evaluates to, a value, and shove it into a variable. In this case, the variable exists. The fact that there's an x on this side and this side is completely irrelevant to us. It doesn't matter. There's no difference between z equals x plus 1, y equals x plus 1, and x is equal to x plus 1. Because here, I'm going to take the value of x, and I'm going to evaluate the expression. I'll do that in a second. And I'm going to take that value and then reassign x to it. Okay, so ask yourself, what is the value of x right here? Well, if you don't remember, just go back through the code. This is easy. Line of code, line of code, line of code. Here x got reassigned the value of 4, so that must be a 4. I'm going to add 4 to 1, and I get a value of 5. Okay, that expression is now done. It has been evaluated, and I have a value, and I'm going to take that, however I got there, and I'm going to do what? I'm going to assign it to the variable x. So when I say to print x, x of course will be 5. Okay, so take-home lesson, assignment operator. There's what's happening on the right-hand side. You have to evaluate something. Right now, they're either a very simple evaluation, they're just numbers. They're expressions. They can, of course, be more complex expressions, as we saw in the last lecture. And eventually, we will do other things like the return of a function call and more complex things. But for now, something has to be evaluated. I have to get a value that I'm then going to assign to a variable. Okay? Don't forget that when you reassign values, the previous value is irrelevant. And don't forget that when you assign the result of an expression, how you got that value is irrelevant. Okay, I'm going to stop here and then we're going to pick it up in a few minutes.